Hey guys, in this video we're in chapter 7 on trigonometric identities and equations, and we're in section 5 on solving trigonometric equations. And we're going through problem 33, which says solve with the methods shown in this section exactly on the interval from 0 to 2 pi. And we're given sine of 3x times cosine of 6x minus cosine times 3x sine of 6x equals a negative 9/10. So first thing we want to notice is we want to simplify this problem as much as we possibly can. And we notice that we have two different angles within a cosine and a sine, and we've got a difference in between them. So we're going to call our 3x our alpha, our 6x and our beta, and use the sine difference identity, which says that if we have the sine of an alpha times cosine of beta minus cosine alpha times sine of beta, that's going to be equal to the sine of the difference of the angles. So then we can rewrite this sine. If we have our alpha as 3x and our beta as 6x, we'll have this be transformed into the sine of 3x minus 6x equals sine of negative 3x. And that's going to be equal to our negative 0.9. And we can simplify this even further because we know that sine is an odd function. That means we can take this negative and bring it outside so that we have negative sine of 3x equals negative 0.9. And these negatives will cancel each other out. So then we're left with sine of 3x equals 0.9. Next, we want to isolate this 3x. So we're going to take the inverse sine of both sides of the equation, which will give us 3x equals sine to the negative first of 9/10. And we're going to leave it like this since the problem asked for exactly here, because if we compute this with our calculator, it will become inexact. Cool. So now we've solved for 3x, and we know that we want x to be within 0 and 2 pi. So what we can actually do is multiply our interval 0, 2 pi times 3. So that will tell us all the values that this can take it'll be now between 0 and 6 pi will now be our interval. Okay, so now we're ready to go ahead and solve for all the values of x that this can take. So let's see, we can erase some of this. Alrighty, so we have 3x equals sine to the inverse sine of 9/10. What we want to notice is that this is going to be in the first quadrant, so that'll look something like this, and this angle will be the inverse sine of 9/10 will be that interval. Here we know, since sine is going to be the same, it's going to be both positive in the first and the second quadrant, we will also have the sine of this angle here be 3x, and this angle right here is going to be the same as this reference angle, so it'll be a pi minus the inverse sine of 9/10. So this angle is pi minus sine to the negative first of 9/10 there. So there we have found another angle, so we can have that 3x equals the inverse sine of 9/10. We can have that 3x equals pi minus the inverse sine of 9/10. So here we found two, and we're going to keep going. So we know that it's going to be this angle here and this angle here, and that will be on any of the rotations around the circle. So we can add 2 pi to this one and 2 pi to this one continuously. So we'll do that for a couple. We'll do 3x, and we're going to add 2 pi to this one, so we'll have 2 pi plus sine to the negative first of 9/10. And when we add 2 pi to this one, we'll get 3x equals 3 pi minus the inverse sine of 9/10. And keep on going, we'll get 4 pi plus sine inverse of 9/10. So now at this 4 pi, we've gone around the circle twice with this one. We've added 2 pi, and then we've added another 2 pi. And here what we're doing in our next step is we have started with this one. We've added 2 pi, and now we're adding another 2 pi. So that's pi plus 2 pi plus 2 pi is going to be 5 pi plus, sorry, that's not a plus, that's going to be a minus. It's going to be a 5 pi minus the inverse sine of 9/10. And we know that when we plug this piece in the right half of the equation, those are going to have to be between 0 and 6 pi. So if we calculate, we have 5 times 3.14 minus the inverse sine of 9/10. We're going to get that to be about 14.5. And if we calculate 6 pi, 6 times 3.14, we're going to get that to be 18.84. So we want all of the values on the right side to be less than this 6 pi, this 18.84. So let's go ahead and calculate one more. So we'll get a 6 pi plus the sine. In doing so, we will find that it will exceed this 18.4, so we won't use this one. So we have 6 times pi. Oh, we can already cancel out because we're adding some. So now it said to solve for x. So now all we have to do is solve each of these equations for x, and then we'll be left with 1, 2, 3, 4, 5, 6 solutions for the equation. And we actually, all we have to do is divide both sides. So we'll have x equals 1/3 times sine to the negative first of 9/10. We'll have pi over 3 minus 1/3 sine negative first 9/10. We'll have 2 pi over 3 minus 1/3 sine of negative 1 to the 9/10. Let's see, let's box this over. Continuing on, we'll have x equals 3 pi divided by 3, or simply pi, minus 1/3 sine inverse of 9/10. 1, 2, 3, 4. We got 2 more to go. We've got x equals, from this equation, 4 pi over 3. 4 pi over 3 plus 1/3 sine inverse of 9/10. And finally, we get x equals 5 pi over 3 minus 1/3 inverse sine of 9/10. So what did we do in that equation? We used an identity to simplify the problem, and then we expanded the interval for the right side of the equation, and then we went ahead and added our rotations to both of the angles that it could be, and then we solved for x, and these are your x answers that we got. Hope that was helpful. I hope you found this video really helpful. The concepts we covered in this video are true no matter what pre-calculus class you take, and the examples I cover are from this textbook right here. And remember, if you're a Baylor student currently enrolled, there is free tutoring on the first floor of Sidrich. You can create a one-on-one appointment online or drop in anytime during our business hours. Please visit our website, www.baylor.edu/tutoring, for more details. Sic 'em Bears.